You know that feeling, right? The blazing heat of a summer afternoon, or seeing your breath on a freezing winter morning. We all know the seasons change, but what if the reason why they change isn't what you think it is? Turns out the real answer is actually way more interesting.
So here's what we're going to do. First, we're going to tackle a huge misconception about summer. Then we'll look at the cold, hard facts to see what's really going on. After that, we'll get into the real reason, Earth's tilt, and how it changes sunlight. We'll take a quick trip through the whole year and then finish up with a cool thought experiment. What would happen if Earth didn't tilt at all? Let's get into it.
All right, let's start with the idea that, just feels right. It's the one that seems to make the most sense on the surface. I mean, when you're sweating through a hot summer day, what's the first thing that comes to mind? We must be closer to the giant ball of fire in the sky, right? And there it is, the big idea. Closer equals hotter, farther equals colder. It's like sitting by a campfire. The closer you scoot in, the warmer you get. It makes perfect sense. It's totally intuitive, but is it actually true? That's a solid theory. But in science, a theory is only as good as the evidence backing it up. So let's put on our lab coats for a second and check out the actual data. If our campfire theory is correct, the numbers should be simple, right? We should be closest to the sun during our hottest months. So let's have a look. Okay, so here's the evidence. This table shows our actual distance from the sun in millions of kilometers for 4 key points in the year: December, June, September, and March. Now let's zero in on June. That's peak summer for those of us in the northern hemisphere. The distance is 152 million kilometers, okay? Just remember that number. So, that number for June, 152 million kilometers, well, turns out that's the biggest number on the list. That's right. When it's hottest in the northern hemisphere, we are actually the farthest we get from the sun all year. So yeah, our simple, intuitive campfire theory, totally busted. Okay, so if it's not our distance from the sun, then what on earth is going on? Well, the real answer is so much more elegant, and it all comes down to our planet's posture. Everybody, meet the real hero of our story, Earth's axial tilt. So imagine a giant stick going right through the planet from the North Pole to the South Pole. That's its axis. Well, that axis isn't straight up and down, it's actually tilted over by about 23.5 degrees. And the key thing is, it pretty much stays pointed in that same direction no matter where we are in our orbit around the sun.
And this is the crucial part. Because of that constant lean, as sunlight streams towards Earth, one half of the planet is always leaning into those rays more directly than the other half.
Now this steady tilt gives us a 2-for-1 deal, 2 major effects that team up to create our seasons. First, it changes how concentrated the sunlight is when it hits the ground, and second, it changes how long our days are. Let's break down that first one. So, let's talk about the concentration of sunlight. Because it turns out, it's not just that we get sunlight that matters, it's how we get it. This is honestly the best way to picture it. Imagine the sun's energy is like the beam from a flashlight. If you point that flashlight straight down at the ground, like spotlight A here, you get a really small, bright, intense circle of light. But if you take that same flashlight and shine it at an angle, like spotlight B, that same amount of light gets spread out over a much bigger, dimmer area. And that is exactly what's happening with the sun. In the summer, when your part of the world is tilted towards the sun, the light hits you more directly. All that energy is focused on a smaller area. It's more concentrated, so it's hotter. But in the winter, when you're tilted away, that same amount of energy gets spread out, becoming way more diffuse and not heating things up nearly as much. So, it really just boils down to this. More direct rays mean more concentrated energy, and more concentrated energy means more heating. That's the secret sauce of a warm summer day. Okay, so we've got the tilt, and we've got the whole direct versus spread out sunlight thing. Now let's put all the pieces together and take a full trip around the sun to see this system in action. This diagram, this is the whole shebang right here. As you watch the Earth orbit the sun, notice the one thing that doesn't change, the direction of the tilt. That axis is always pointing off towards the same spot in space. It's this stubborn, constant lean combined with our movement that creates the seasons. So let's follow the northern hemisphere for a year. In June, you can see it's tilted right towards the sun. That's the summer solstice. Then we move along to September, and the tilt is kind of sideways to the sun. Hello, autumn. By December, we're tilted completely away from the sun. That's the winter solstice. And then we come around to March, we're sideways again, and that brings us spring.
So let's just compare the two big extremes. On the summer solstice, we're tilted towards the sun. This gives us a double whammy. We get the most direct, concentrated sunlight, and it's the longest day of the year, so we get more hours of it. But on the winter solstice, it's the complete opposite. We're tilted away, so we get weaker, spread out sunlight. And it's the shortest day of the year. Less energy for less time. That is the perfect recipe for winter.
We've seen just how important that 23.5-degree tilt is, but to really appreciate it, let's just do one last little thought experiment. Let's imagine it's gone.
If our planet just spun perfectly upright, without any tilt, the sun would hit the same places at the same angle every single day all year long. The equator would be trapped in a permanent, blistering summer. The poles would be locked in a deep freeze, and everywhere in between would just have one boring, unchanging season, forever. No spring flowers, no long summer nights, no crisp autumn air.
So in the end, the amazing variety of our year, the very thing that makes our planet so vibrant, it's not about being closer or farther from the sun. It's all thanks to our planet's quirky, constant 23.5-degree lean. So the next time you're enjoying that summer heat, or you see your breath on a cold day, you'll know exactly what to thank. Our world's amazing, season-making tilt.